Good morning, my YouTube viewers. It is Crystal here. I'm just here because I want to give you a code review on Cackle's Playground Series, Season 3, Episode 9. And I was up in the middle of the night working on it, so I'm giving you the code review this morning. I got a score of 12, and the best score was like 11. So I scored worse than the best score. And if you go into the Playground series and look at it, you'll notice that the other people who gave their code, they did their machine learning much differently than I did mine. So I also got a comment on it. And we'll look at the comment. It said, "Nice one with Keras, upvoted." So that means I got an upvote on my Jupyter notebook. So this is what I submitted to the competition in the middle of the night. I did it on Kaggle's free online Jupyter notebook. So you don't have to worry about having a Jupyter notebook to do your work on. So the problem statement for this competition question is the data set for this competition, both train and test, was generated from a deep learning model trained on the concrete strength prediction data set. Feature distributions are close to, but not exactly the same as the original. Feel free to use the original data set as part of this competition, both to explore the differences as well as to see whether incorporating the original in training improves model performance. So what we did was we imported the libraries. We imported NumPy SNP, that's your numerical computation library. We imported Pandas SPD, that's your data processing library. We imported OS, which is an inbuilt module into Python, which goes into the operating system. We imported matplotlib.pyplot.splt, that's your graphics library, and we imported Seaborn SSNS, which is a graphics library written on top of matplotlib. We also imported sklearn later on in the program, which is a machine learning library, and we imported Keras, which is a neural network that we used for this competition. We loaded our files. We used OS to go into the operating system and get the files, and we got the files. We got train, test, and sample submission. We then used Pandas to read the files, and then we read the 3 files and converted them to 3 data frames, being train, test, and submission. So you can see train here, it's 10 columns. The 10th column is strength, and that's what we're going to be predicting on in the test set. So we checked for any null values. We didn't have any null values, which is good because we didn't have anything to impute. We checked the test set, has only 9 columns. So the strength is not there. And that's what we're going to be predicting on. We're going to be predicting on the strength. We check for any null values. There's not any null values, so that's good. We don't have anything to compute. We check submission. This is the format that Kaggle wants to see when we submit our work. Now we're going to analyze train. We're going to describe train. So train only describes the numeric columns. It gives you the count, how many columns, how many rows there are, the mean, standard deviation, minimum, 25%, 50%, 75%, and maximum. And then we check info on train, so you can see that all of the columns are numeric, which is good because we don't have anything to encode. And now we use Seaborn to create a plot of the target. So that's what the target looks like. And then what we did was we did the value counts on strength to check to see if there were any rows that where the strength only appeared once. And there were some rows where the strength only appeared once. So what we did was we filtered out those rows where the strength only appeared once. So we have is multi equals train strength dot value counts is greater than 1. So that means is multi, anything that's greater than 1 goes into is multi. Filtered equals train strength dot is multi dot index. So filtered means anything, takes anything in train that's in is multi. And then train equals filtered and train. So you see that train has 5392 rows, which is a little bit less than before it was filtered out. So now what we're going to do is we're going to check our target again, and you can see that this is the form that the target makes. So I think it's just slightly changed from the original one. Now what we want to do is we want to check the number of unique values in each column. So you'll see that each column has quite a few unique values in it, except for age and days. It has only 15 unique values. So now we do a box plot on strength and age and days. So you can look and see the strength of the concrete as compared to how old it is. And you can see if it's between 90 and 100 days, it looks like it's the strongest, really. Now we do a scatter plot on the cement component and strength. So that's your scatter plot. That doesn't really tell us a whole lot, but I decided to go ahead and do the scatter plot anyway. And now what we're going to do is we're going to combine the train and test data frames to make one big data frame and calling it combi. So target equals train strength. Combi equals train dot drop strength, axis equals 1 dot append test. And so now we've got one large data frame instead of the two smaller data frames. We're going to drop the ID from the combi, and the reason why is because you don't need it. The reason for that is because every row is indexed, and it probably just adds noise to the system. Now we're going to create a heat map. Core equals combi.core sns.heatmap core. So you can see this is the heat map, and we don't have any columns that are really highly correlated. So that's good. So we don't have to filter out the highly correlated columns. And then this is your core, so you can see what the correlation between each column is. Now what we're going to do is we're going to normalize combi. And what we do is we take combi and we convert all of the cell values to a value between 0 and 1. And the reason why that is because the model does a better job of training, fitting, and predicting if the values are in close proximity to each other. And now what we do is we define our independent and dependent variables, which are x and y respectively. So y equals target, x equals combi, row 0 to the length of train, x test equals combi, the length of train to the end. And then now we define the variable feature len, which is the number of features in x. Now what we're doing is we're using train test split to split our data set up into training and validating sets. And we also check the shape, so you can see the shape is good as well. So we've got 4,852 X train, 540 X val, 4,852 Y train, 540 Y val. So now we check our model, And in this instance, we're checking Keras. So we import Keras from Keras.models, import sequential from Keras.layers, import dense. And we create our neural network. So model equals sequential, model.add dense 500, input dim equals feature length, activation equals ReLU, model.add dense 100, activation equals ReLU, model.add dense 50, activation equals ReLU, model.add dense 1. So that's your output. And model.add density, and then model summary. So we check the summary. So you can see the summary here. Now we compile the model, and we compile it on mean squared error loss. And then we fit the model, we fit X train, Y train of epochs of 500. So we give it 500 epochs, which is 500 iterations. And then we just go on down our 500. Do this. So, and then what we do is we predict, and then with the X train, Y train, we had a RMS, or a mean squared error, of 113, and then we predict on the validation set, and anything that's under 0, we make it 0. Now what we do is we get our RMS, that's root mean squared, of the y-val y-pred, and it's a 13, so that's your root mean squared error is 13. And now we plot the actual values against the predicted values, so you can see where they are on the graph. And then what we do is we create a data frame, and we plot the actual values against the predicted values. And now we predict on the test set. So prediction equals model.predict x test. Prediction, and then we filter it out, so anything that's less than a 0 becomes 0. And then we have our prediction, and then we set our submission up. So submission strength equals prediction, submission to CSV, submission index.false, submission equals PD read CSV submission, and so you can see our ID and our submission. And then when I submitted that to Cackle, I got 12. So we can come over here to the Playground series, episode 3. We're just waiting for it to come up. Look on the leaderboard. So it said right here on the leaderboard, got lots of people. I'm 43 out of 45. So a lot of people have gone in and worked on the competition since then. But I've got 12.93, and the highest was 11.8. So the highest was only like 1 point better than mine. And if you look at the code, so I mean, I made my code public so you can see my code. But if you look at the code, whenever I first did it, and that was in the middle of the night, there was this one guy, I don't know if I can see him, but there was this one guy, this guy right here, XGB TPS SE E9B underscore V1, his code looks really unusual, so it's really hard to see. So yes, he did score better than me, but his code is really hard to read. And so there we go. And that's it for the code review. So I'm going to go ahead and conclude this video because we've gone through the code review, which is what I wanted to do. If you like my video, please like, subscribe, and share. I would like to thank all of my subscribers for supporting my channel. Thank you so much for watching this video, and I look forward to making more code reviews for you in the future.